Welcome back to Low Stress Math with Mrs. Bono. We are in Unit 6, Solving Systems of Equation, Lesson 7, More Practice Solving Systems of Equations. And I really want to talk about the different ways you can solve the system. The three that we've learned are elimination, such as this one. We have a positive x and a negative x, so we could just eliminate an x, solve for y, and get the system. Or down here, where you have y equal to something, and you can substitute that up here for y, and that's substitution. Or this one, they're both equal to y, so of course they're equal to each other. Now this one's going to take a little thinking. That's why I skipped it, because there's two different ways you could solve it. You could do elimination and eliminate the y and solve for x, or you could do elimination and eliminate the x and solve for y. It's all about what you choose to multiply by. Now, if I choose to multiply by -1, I could eliminate the y. If I choose to multiply by -2, I can eliminate the x. Now, that's not really useful right now with this particular problem. I'm going to eliminate the y because I like to find x first. But if you're doing a problem such as the problem we did on the page before, and it says specifically how many cones, and I made cones x, it didn't matter what y was. I had to eliminate that because it didn't ask me about y. So sometimes elimination is all about what you're really looking for, especially with word problems. So let's take a look at this problem. Like I said, I am going to eliminate the y. Why? Because just that is how I am. So I'm going to highlight up here because, you know, I like my answers to be highlighted. Plus, it kind of like differentiates between the problems. And I am going to separate my problems with a little double line because that too, very useful. Here we go. And now, oh dear, Bono, you've made a mess. Try not to make messes, old woman. Here we go. So for this one, I'm going to keep this first problem. First equation, the whole thing is the problem. I don't know. -2x plus y equals -12. And then the second equation, I'm going to multiply times -1. Negative times negative is positive 1x. Negative times positive is -y. Negative times negative is positive 5. Okay. Now, you see, I didn't put the coefficient here, but I put it there. Why? Because positive y, negative y, that's what's going to disappear. But I need it over here because -2 plus 1 is -1. And I want to make sure I have the coefficient there to help me. So this is 0. -2 plus 1, -1x equals -12 plus 5, -7. Now, when I divide by -1, it does the same thing as when I multiply by -1. All it does is change the sign. That's good. So I get x equals 7. Now I have to go put that up into one of the equations and solve for it. It doesn't matter which equation. Let's do the second one. -1x plus y equals -5. Why is that -1 there? Because I have to multiply times 7. -1. Now I substitute my 7 in here. Plus y equals -5. -7 plus y is -5. Add 7 to both sides. And I get y equals positive 2. Opposite signs subtract. Keep the sign of the larger number. Bam. We have our first response. 7, 2. All right. The next one, they already have the same variable and opposite signs, and I just wrote all over it. So I have x plus 1y equals 3. Negative x plus 1y equals 9. These get eliminated because same variable, opposite signs. 1 plus 1, 2y equals 9 plus 3 is 12. Divide by 2, divide by 2, y equals 6. And I'm going to say it for the millionth time. I love elimination. It makes it so much easier for me to solve these problems. But now, look, I have a y. I solved for y first. So I have to find the x. So up here, it says x plus y equals 3. X plus 6 equals 3. Subtract 6 from both sides. And x equals negative 3. Ba-bam. But when I put this up into the answer place, the y goes, this y goes second. So it's alphabetical. X, y, negative 3, 6. And whenever I do it, I make sure I put the parentheses around it because, I want to get full credit for my answers. All right, down here. Well, these are both equal to y, so they're equal to each other. So I have x equals, actually I'm going to put 1x there. I'm going to need that coefficient in a minute. Negative x, well, negative 1x, write it right, plus 2. And here, I have to go over the equal sign. When you're on the same side, you do the same operation. When you're on opposite sides, you do the opposite operation. So I'm going to add 1x to both sides. I get 2x equals 2. Divide by 2, divide by 2, x equals 1. Ta-ta-ta. And I'm done. Now I'm going to substitute that up in the first one. Y equals x. Wait a second, y equals 1. Because y equals x just means that the x and y are the same number. I could check it here. I could say, oh, negative 1 plus 2 is 1. That works. So I have 1, comma, 1. Nice. Last one on this page. So what am I going to do here? This is a substitution because they're not in the same order. That's how you know it's going to be substitution. I mean, look up here. X, Y, number. X, Y, number. That's called standard form. Now down here, this is in standard form, x plus y equals 2. But this is in slope-intercept form, y equals mx plus b. And when that happens, it's almost inevitably going to be a substitution. So I have 2x plus, and I am just straight up going to substitute that into there, 3x plus 2 equals 2. Now there's no parentheses in multiplying because this y doesn't have a coefficient. All right, 2x plus 3x is 5x plus 2 equals 2, minus 2 from both sides, and 5x equals, 0. That's okay, divide by 5, divide by 5. Now I know x equals 0. Bam. And I can go back and I can substitute that in to either equation. It doesn't matter. But I like to substitute it into the y equals mx plus b one. So y equals 3x plus 2. Y equals 3 times 0 plus 2. Y equals, well, 0 plus 2 is just 2, so y is 2. There we go. X is 0, y is 2. And I'm going to pause. I'd like you to try the problems on page 36. It's all the graphing. Take care.